So, what are the main points about small and large covalent molecules? Well, let's first start just reminding you as to what a molecule actually is, because we can often get confused about the terms molecules, atoms, compounds, elements, and use them incorrectly sometimes. So, a molecule is simply something that consists of more than one type of atom. So more than one type of atom chemically bonded. So you've got to bear in mind that this can be atoms of the same element, such as oxygen, or hydrogen, or chlorine, but it can also be atoms of different elements, such as water, carbon dioxide, ammonia, methane, etc., etc. Now, for a molecule, substances that we would say consist of small molecules can consist of anything up to 8 atoms. So anything up to around 8 atoms that are chemically bonded. Now, when we have small molecules, they are often together, but not necessarily chemically bonded, but they are of the same structure. So when we have lots of molecules of the same structure, we call them monomers. So lots of molecules of hydrogen, oxygen, chlorine that aren't chemically bonded, you would call monomers. But when it comes to covalently bonded molecules, they can sometimes bond together, and these monomers can form what we call a long-chained polymer. Now, the polymers are simply covalently bonded substances, and they're all the same, so we say that they are made up of repeating subunits, like so, made up of repeating subunits, and they are obviously held together by strong covalent bonds. You'll have to excuse me, I've got a bit of a cold. Now, the molecules themselves are attracted to each other, so different polymers are attracted to each other by weak intermolecular forces. Now, an intermolecular force is simply a force that is between different molecules, okay? So large molecules have more weaker intermolecular forces, which, if you've got more forces between molecules, that means you need more energy to separate them. And if you need more energy to separate out these different molecules, what do you think happens to boiling points and melting points of polymers as they increase in size? They get higher and higher and higher. And that's an important correlation to try and remember, okay, that as the size of the molecule increases, you've got more forces holding those substances together. So therefore, the melting point and the boiling point of those substances increases.